So good to be with you guys today. What I want to do today is a few fix-ups, fixer-uppers, refactorings, just a tiny few things that I want to just sort of patch or whatever you want to say. Nothing really bad, but let's do that real quick, and then I'll tell you what we're really going to be doing today. The first thing I want to do is the entity manager here. I noticed that the draw function here, we're kind of requiring an entity to have a draw function because we're not checking in any sense, and we're just assuming that that entity has a draw function, and if it doesn't, then you get you're going to get an error. So what I want to, it's real simple. All I want to do is I just want to check and see if this entity has a draw function. So I'm just going to do that just like this. So that allows us to optionally have a draw function for an entity. We could do the same thing for update right here. We could say else if e.update, then it's like that. But I'm kind of thinking that most of the entities are going to have an update function, and I don't, at this point, I don't see any reason to actually check for that. I'm just going to assume, but I'll leave this code commented like this. So just in case we ever want to come in here and say, you know what, we don't want all of our entities to have an update function, then we can just uncomment that code and we should be fantastic. Okay. And then there was a couple other things here in this test scene. I had this sprite here, or SPR variable, that is no longer being used. And then also, we really don't need to do all of this stuff in the enter function. So I'm just going to pull this over here, and while we can still utilize the enter function if we need to, we don't really need to with this particular scene. So I want to make sure that all that still works. The little fella still punches. Good. Okay, that looks fantastic. Now, what are we going to be talking about today? Well, you've probably already looked at the title, and that's probably why you're here. So you're probably like, oh, okay, get on with it already. Okay. All right, we're going to be talking about tweening, which is the movement of a value from one particular value to another value. So the movement, say, of a position from one place to another place. That's typically what people think about when they think about tweens, or maybe a rotation, or just basically any kind of thing. Alpha values or a color. You can tween all sorts of things. Well, what does a tween look like? Here I have a nice wolfram alpha. We'll be playing with that some. A tween looks like this. Now you look at linear, and that's like if I want to move something from one position to an end position, and then I just move it based off of just a regular linear sort of velocity, if you will, or just the same constant velocity. Then you're just going to get this linear movement. As the time increases, whatever the value that you are tweening just increases sort of linearly with that time. But that's nice. But as is quite evident in the real world, that's almost never the way things happen, right? You see things typically will speed up, they have an acceleration that occurs, or they have a deceleration that occurs, such as that one, that they slow down when they get to that end point, or maybe perhaps they do both. They accelerate and are going fastest in the middle, and then they decrease. And if you look at all of these, I just like this easings.net because it kind of gives you a nice little visualization of a lot of the common tweens. And if you look at these, you'll see an ease in, and then you've got the ease out. And of course, the ease in means that at the beginning you get this slower sort of change of the value, and then at the end you speed it up some. And then ease out is just the opposite. And then you have this ease in and out, which is you just combine the two. So we have this sine, and then you have this quadratic, which is really just involves a squared term, and then the cubic just involves a term to the third power. The quartic is a term to to the fourth power, and then quint is to the fifth power, and then exponent just uses an exponent to do the easings or the easing curves, and then the circular, I believe it uses, I'm not sure what this one, I haven't looked into the math on this one. But then you've got this ease in back and ease out back, where you can see, if I will say that these lines, so this lower line you would consider to be 0. So you've got these tweens are pretty cool because the way that you set them up, the way that we're going to set them up, is they go from what I would say 0 to 1. And so it ends up being a ratio that you multiply your change by, so that at the beginning you have no change, and then by the end time that you set up, you have changed, you have basically moved that value all the way to where you want it to move. So you can consider this 0, or this part down here on the y-axis, as the 0 or the start value, and then this would be, or 0, this would be 1. So you got 0 to 1. And it's how you move, or it's how you change that value from 0 to 1 will affect the way that whatever your tweening looks like. And then, of course, I like these. These are nice, the ease in elastic and out and the bounces and stuff like that. Those are really neat things. But you can come up with your own easing functions, and that's partially why I've got Wolfram Alpha up here. We'll be messing around probably with this a little bit, maybe, depending on how much time that we have. And then there's another great website here, which is called, well, here's the address. You can pause the video and get it. And that's Understanding Easing. And so you can sort of look through here and kind of see, if you want some more information, you can kind of see kind of how things work. But let's, real quick, let's copy this test scene, because I want to make a separate scene for this. So let's copy this test scene, and then let's just paste it. Did I just copy and then paste? Paste. I'll rename it. We'll rename it to Tween Test. Okay, so this is Tween Test, so we need to rename it here. Tween Test. We'll get rid of the player. And we probably don't need that because we actually have that in main, honestly. See, we have that escape. Don't we have that escape in main? Thought we did. If we didn't, we should probably put that in there. I'll leave it in here for now. And instead of clearing the graphics to this bluish color, let's go to something, I don't know, I don't know, 128. Do that, and then we'll go back into main, and we'll add that tween test to our table of valid scenes. And then we'll go ahead and switch to Tween Test. Let's verify that we have that working correctly. Yeah. Although I don't know that I really want green. Let's go back down and make it a sort of a I don't know, just maybe a gray. I know gray's boring, but let's make it a gray. And then what else we want to do? I want to label, because what I want, well, I'll pull this back up. I want a couple of things. What I want to do is we're going to have in order to watch our tweens, to sort of debug them, we'll get us a little rectangle. Let's have a little rectangle that starts somewhere, and we'll tween it to another side or to another location. So I want to, and we'll just go ahead and use locals for this. So I'm going to call it local position, and we're going to make a table, and we'll say, we'll have in the table, we'll have an X, and that X for here, we'll just say 5 or something, and Y will equal 150. And then in our draw function, we can say love.graphics.rectangle. We'll do a fill, and then we'll just do position.x, position.y. And I think it's width height, right? And I believe that's all you need. Yeah, see, there he is. So we can start him. Let's actually start him at 0. It makes more sense. So that will be the little thing that we'll be moving around just to test our tweening functions. And something else that I'm going to want eventually is we'll kind of have this as sort of a, like I said, a test bed for this, and we'll add some keys, and we'll be able to change the tween, the easing function that we use for the tween. And I want to be able to see what easing function we're currently set to. So that means I want to label. So what I want to do is let's add a label. And we will just create that as a local, and we'll add it. Label equals label, and label will have an X. In this case, we'll do 0. Y will also have 0. We'll start it in the upper left-hand corner, and the width will be, let's say, love.graphics.getWidth. So we'll make it the full width of the screen. And the height, we'll just do 50. And let's see, I forget what the rest of the label constructor is. Text. So that's the only other thing that we need is text. So we'll say no tween. So just, and then we'll add that to our entity manager for this thing. Or not super, sorry, it's self.add our entity manager, :add, and then we'll add the label. And we should see the label show up, and there it is, except we need to come down a little bit, I guess. Let's check that. I'm going to go over here and uncomment our little debug rectangle for the label. Okay. So the Y is, why did we do it that way? I'm trying to remember why we did it that way. I mean, if the X is the upper left-hand corner, then really the Y should be too. We may have to come back and revisit that, but in any case, we'll just go ahead and change it right here. And let's say 15 maybe, or maybe it's 20 that's required. We'll see. Yeah, well, that's fine. We'll just leave it like that for now. So we'll use that label a little bit later to tell us which tween that we're looking at. Okay. Then we want a new library module. We'll call it Tween.lua. And kind of like the keyboard, I'm thinking just like the keyboard that we did. Where is it? Keyboard. We just made it a plain old module. We didn't use class or anything. I think we'll do that here. And then we'll make it a global variable so that if you want to add tweening to your project, you just come in here and you do something like this. You say, make a global variable, and then you say, hey, that's we want to require that there. And then we probably would want, we'll definitely want something like this, tween.update, like that. And you know, I'm not thinking that we're going to need any kind of special self stuff. Maybe we should go ahead and do that, and so that we have access to. No, I'm going to leave it like this. We're just going to do the dot so that we're not going to have any kind of self variable or reference. So we need to come up here in the tween module, our brand new module. We'll just say t equals an empty table, and then we'll return that t. And then we'll go ahead and let's go ahead and make an update function since we are calling that. All right. Then we need somewhere for our tweens to live. So let's make a variable called local, or we'll make a table called, let's call them active tweens. And that'll be an empty table also. And in here, what we'll do is we'll just go for, and we'll probably want to go backwards when we're going to do these tweens, because what we'll do is each of these tweens will have update functions, and we'll update them, and basically we'll add this delta time to them, and then when they know they're done, we'll have them return like a Boolean or something that says maybe when they're done they return true. So then we could do something like so for I equals, say, active tweens to 1, I think, and then step is -1. So we'll go backwards through them, and we'll go backwards because when they are, we'll say if active tweens of I and then we'll call, basically this will be actually the tween will be a function, and maybe we'll call it, and we'll definitely have to call it with the delta time. But if say that returns true, then we'll say table.remove. So we'll remove it from the active Tweens table because we want to get rid of it. We don't want to service it anymore. We'll do end right here. And then, you know, to do could be to do if the tween has, probably up here, if the tween has a completion function, then call it or something like that. We may want to call back whenever our tween is finished. So we could make that optional. So what we'll want is we'll want what I'll call easing functions. Place easy. Let's just call it, this little area will be easing functions, which really, I'll show you, that's just going to be these. It'll be equations that will output these things right here, right? All right. Okay. So that's where our easing functions are going to be, and then we need basically we need a function. And we'll probably make multiple of these. We'll need a function that is basically the tween function that creates a tween for us. So maybe we should, since we've named the module tween, maybe we should have a function called create. I don't know. The jury's still out on that. Maybe we don't call it create. Maybe we do call it create. I'm not sure. Here we'll call it create. We can always change the name later, right? So what we'll want is some sort of target object or target table. So we'll want to do something like assert the type of the target equals table. Otherwise, we'll say target parameter must be a table. Because we want a table, because that's how we're going to get, that's how we'll need it to be a table in order to be able to change the values that we want to change. And then we'll want to know the property name that the user wants to change, and we'll probably want to assert on that too. Probably want to assert that the property name is a string because it needs to be string like so, and we'll say target parameter, property name parameter must be a string. And then we'll have, let's say, there's a couple of different possibilities here, and that would be, we want to create a tween, and the target table would be this, and then the property name that we want to tween is here, and then we could say we want it to go from this and then to this. And then we would want a duration. But I'm kind of thinking that maybe we get rid of this from. Usually you just, let's get rid of the from for now. We could create another one of these that has a from, and then we can go from there. But for now, let's just create. So wherever, basically this will be wherever that property is, whatever value it is at the current point that you call this, that from will be stored internally. So you won't specify the from, it'll just be wherever it is when you create this tween. That'll make sense hopefully later. So we have the target, the property name, and where we want to tween it to, or the value that we want to end with. And how long is that going to take? And that duration, let's say that's in seconds, because our DT, or our delta time, is also in seconds, so how much time has passed between each frame. And let's just real quick sort of block out what this would look like in order to make that, or to change that property to what we want it to be, to tween it. So the target, and then we would say property name. So that's going to be whatever that property name is, the target, and then you can refer to it that way. So that would be equal to some kind of, we'll go ahead, well, let's do this. Let's create a local from, and that's going to equal to target property name, right? Because that's where we start, because we will need that because of the way that we're going to change it. So we'll say that's equal to from plus, well, the 2, really what we want is the difference between where it comes from and where it goes to, because that's how we're going to, so we need a diff or a difference, and that's going to be 2 minus from. Okay, so that we want to do the following. We want to say the target property name equals from plus the difference, and then we want to multiply this by what I would call, well, what is a ratio, and that is we're also going to want to keep track of the time that this tween is taking, because that duration, we want, basically what we want is this tween will take the duration, so whatever this duration number is, that's how long the tween will take to go from the starting or the initial value to the final value. And in order to, and what that looks like is that would be the following, which is from plus that difference between to and from times a ratio, and that ratio will be t, which is the amount of time that has elapsed so far, divided by duration. And when the t is equal to the duration, then this, it becomes 1, which means it becomes from plus difference, which is the 2. It ends up being what we want, that final value. And when t is 0, you get from. So you see what I'm saying? So this is just a ratio that we will clamp from 0 to 1. And then when it gets to 1, we know that we're finished because the property is now where the user specifies it to be. Gosh, that just seems really, I don't know that I explained that very well. Hopefully you get some of what I'm saying there. And if you don't, as I already said, the article here on understanding easing can be quite helpful. But just know that this is a ratio that goes from 0 to 1, and that's how we're going to control that, the way that movement looks, right? From this linear, which is just a 1-to-1 mapping, to this, to something like the I don't know, the Quadratic function, where it basically, when you're, so if this x-axis is time, and then the y-axis would be movement or change from, and then this upper line would be the 2 for whatever it is that you're tweening. So the time, so you know, this would be like, okay, we're already over halfway done, but we haven't even gone halfway up. That's valuable because that's what we want. We want it to look really cool, depending on what tween we're using, or what easing, we call them easing functions that we're using. So, and of course, this has all got to be wrapped in something, because we're going to have to change, we're going to have to do something like t equals t plus delta time, because we have to be able to change that somehow. So really, this create function will need to probably create, let's have it create a function that we can stick in here in the active tween, so that we can basically do well, we can do what we're doing here, which is basically do some kind of update on it and give it this delta time. Hopefully that makes sense. So, well, we have our initial value, which is our from here, our current time, which is 0, and what's cool about Lua is we can, since in Lua functions are first-class citizens, we can create a function right here, and we'll say we want a dt that comes in. We'll go ahead and end. So we're going to assign that to this updt, or let's just do this update function, okay? So inside of this, we can also refer to variables outside of it, which is very nice because we're going to need to do that. So the first thing we want to check, we want to see if that t that we're accumulating, and let's stick this stuff in our function too, because that is what we need. This is where we're accumulating that delta time. We're adding it up. If that is greater than the duration that was specified, then I want to do a couple of things. I want to set, even though it probably is, but just allowing for floating point error, I want to set the target property, or the property that we're dealing with here. I want to set that equal to the final value. And then we will say return true. Remember, we said we want it to return true when it's done. Otherwise, we'll go down here and we'll say return false. So it's not finished yet. And that makes all this stuff work. It should anyway. So this is where we're clamping that, right? We're clamping that t to be from 0 to no more than 1, because remember, when t gets to duration, duration divided by duration is 1, and that's exactly what we want. We're done. We know we're finished. Otherwise, here's where the actual tween occurs. Tween the property here. So this t divided by duration, as I said earlier, is what you would call the ratio that we've clamped from 0 to 1. And so what we want to do is we want to take this ratio, and if we did it, let's see, can we just, let's see, are we okay with that? Yeah, so far. Let's go ahead and add this in, because I'm going to leave it like this, because this would be linear. This is just a linear function right here. So time divided by duration. That would be what you would call a linear ease, which would give you this right here, just that linear curve. Let's add that. We've got tween, we've got there. So let's take and go into test. Not test. We want the tween test. Let's do. Oh, wait. Something else we need to do here in the tween. We've got this update function, and then let's add that to our active tweens, right? We need to do that. So we got to add tween to active. And we may want to return something here, maybe return something so we can stop or complete the tween early. But for now, we're just going to add it, and it's going to do what it does, and then it'll be taken out whenever it's finished. So back here, let's make a else. Let's do an else if, let's say, if the key is space, then let's create a tween here. Tween.create, right? So we'll create a tween, and we want to tween this x value. So the target is the position, and the field, or the property, is the x property. And that's going to go, let's tween it to 200. And let's say that it's going to take a second to do. Now, I probably left something out, but let's see what happens when we do this. I'll hit space. Target parameter must be a table. Oh, I must have, yeah, I did. It's not, we don't want a colon there, we want a dot. So that takes away this whole self-implicit thing. And because we only want to call it with a dot, we don't want to refer to any kind of self. And I'm going to hit space, and that's in tween.27. So that looks okay, but we're not. So it's complaining that dt is nil. So did we not, in main, have we not, tween.update dt. Let's check dt here just real quick. We'll print it, and I'll show you what it looks like here. Whoops. Well, how about that, ladies and gentlemen? It's nil. Go back here. Tween.update DT. Did I do that? Oh, I bet I did. Did I? Yeah, I did the colon there too. Sorry about that. It's expecting that first parameter to be self, basically. There we go. Okay, that should work. I've got debugging mode on. Let me turn that off. Okay. Here we go. And actually, let me get rid of that. We're not printing anymore. I hit space. See? Linear. A linear tween, and that's what it looks like. It's just constant velocity, right? Really, that time we're basically with this ratio, we're manipulating sort of what time looks like, and with linear, it just looks like a linear, plain old, non-changing constant velocity, right? And how long did we set that for? 1 second. So we had something like 1,000. Well, let's see. 1001. Okay. So it looks normal, like what you would think. So let's make it to where we can change the type of easing that we want. So that means that we need another parameter, and let's call it ease function. And then with that, we'll come down here where we're doing this. And instead of that, we'll call the ease function, and we'll call it with that parameter, because what we want is that ratio. So we want the ease function to do something with that ratio to make it look like one or any of these particular ease functions. And we can start with, of course, the linear. And all that's going to do is we're just going to return that ratio, because we already know that that's linear. Okay. But let's say we want to do like the quadratic. Remember, that's just some sort of term squared. Quadratic, that's kind of what that is, what it means. Let's go over here for Wolfram Alpha, and let's just square a term. We'll call it t for time. And let's limit t to be from 0 to 1, like that. Right, so we'll compute it, and look what we have. Let's see, does that look like the ease in quadratic? Yes. Yes, it does, and it is a squared term, which means it is a quadratic. So that's exactly what we want. We just want this squared. So I'm going to copy this, and we'll say quad, and I'll do underscore n. And so what we want to return is ratio times ratio. Whoops. Ratio. We can leave it like that, but what I want to do is we'll be needing some other, let's do an alias here, which is going to be power. We're going to take the math.power library function, and we're going to assign it to pow. And that's just going to take the base, which is our ratio, and then means we want to square it. So that's all that means, right? Let's see if we can specify that quadratic n over here where we create this. So we'll say tween.quadratic n. Let's see if that works. Should work, and you see it does. And if you notice, check this tween function. So what it does is it starts out kind of slow and then speeds up at the end. So let's do that again. Let's do that again. Run it. And watch how it starts out slow and speeds up at the end. See? It's already different than linear. What I want to do, we'll continue this next time, and we'll add some more of these easing functions in. And then, maybe we can figure out some of our own, and you can. And like I said, Wolfram Alpha is a great place to try some of these things out, because you can graph them and figure out what you need to do, where they need to be, and everything. But until then, I'll see you next time.